Oh, good morning. Labguy here. Thanks for joining me for coffee this morning. I want to talk to you about some of the projects in previous videos that appear to have ground to a stop. None of my projects are ever dead permanently, though they can get delays up to years. So let's look at some of the projects that some of you may be interested in seeing completed. The first one, and most annoying to me because it was so simple it should have been done by now, the PV 4800U restoration. As anyone who restores tape recorders knows, rubber belts are the bane of our existence. We're down to one flaky rubber belt, and I am still doing homework to locate a modern replacement that will pop in there and work. And when that's done, I'll do a final video about that, listing the part numbers of all of the valid belts that work in this machine, so that for people who have JVC, PV 4500 or PV 4800 portable videotape recorders, you will be able to restore your machine's belts at that point. Can't guarantee anything else, but at least you'll get your rubber belts replaced and possibly be up and running. There were 2 rubber rollers in this machine that I sent to Terry's Rubber Rollers and Wheels. Terry rebuilt them. He did an excellent job. They are perfect. I'm happy as a clam, and you know how happy they are. Next project was the image dissector camera. That is a live project, believe it or not. So I was at the point of building this high voltage power supply for that project. It contains a 3000 volt DC power supply module and a voltage divider chain of resistors with all the taps coming out through feed-through capacitors. I have been under the impression for most of my life that feed-through capacitors of approximately that size have a several thousand volt voltage rating. Once again, I was wrong. These are 600 volts maximum. So you see the 2 empty holes. This one was 1500 and this was 1400 volts. Those 2 are solid shorts. They're as shorted as a quarter 20 bolt. There you go. And the rest of these, until you get down to 600 and less, not reliable. There is a solution to this, and that is I bought a 3D printer. I will print my own high voltage feed-throughs out of plastic that will thread into those holes, and they will have a little tiny pinhole through the middle where I can insert a wire through them and be able to solder my wires on and off the outside of this box. That was the beauty of that design. It was a module that could be removed with relative ease so that it could be serviced. That project is still on the table, still on the drawing board, and still in progress. So, 3D printer. I'm in the middle of building a 3D printer from a kit, and of course, why am I in the middle of it? Usually it's my fault when a project dies in the middle. This time, I bought the kit on eBay, $265. It is a Prusa i3 clone. And there was a component missing from the kit. So I contacted the seller, yada yada yada, back and forth, and they're sending me the part, and that was 2 weeks ago. I'm still waiting. Of course they sent it slow boat. They don't want to lose any more money than they already have by underselling these products. But not my problem, not my concern. I just need that part to get this 3D printer running, and at that point I can make my little feed-throughs. I can make supports for the copper canister that I'm building that goes around this tube. If you recall, this is the RCA 2F21 Indian head monoscope tube. When this tube is running, it will produce the Indian head test pattern. I need a new tongue too. A historically significant project. Still on the drawing board, still on the assembly table, still in progress, on hold because of mechanical mounting issues and my inability to build a working magnetic horizontal scan circuit. I've never built one in my life that works. Even when I copy them component by component or dismantle one from a television chassis, put it on my own chassis part by part, identical to the original, if I touch the parts, the circuit will not work. I know that's kind of a fatalistic way to look at it, but this has been the story of my life. I have been in this for 30 years, 40 years I've been into electronics. I have yet to build a working magnetic scan horizontal circuit. I can make lots and lots of smoke. You turn them on, they either scan perfectly or they go straight up in flames. There is no in between. So that's the chief. The other project that I really want to get into, but I don't want to start a new project until I finish something to show you that I finished projects. This is reaching a phase of humiliation that's indescribable. So, you already know about my latest obsession. Telefunken. D5-100W. Black and white, electrostatic deflection, television picture tube. Now, who would not want to build a project around that? So we're back to power supplies. I have the data sheet for the tube, and the tube wants 2,000 volts. The designers designed it for 2,000 volts, 2.000 kilovolts, according to the data sheet. And I assume that's because they need to get quite a bit of beam going to get some brightness out of this thing. Why did they use such a funky tube? This went into the Sinclair Electronics MTV1 multi-standard international pocket TV. This tube can scan at any speed you want. It's electrostatic. Remember what I said about magnetic deflection. So what would Labguy do with a tube that can scan at any speed? Maybe he's going to scan it at any speed. Yes, there is that. Let's look at another aspect. Black and white picture tubes have P4 phosphor. P4. That's that bluish white that we're all familiar with from black and white televisions. This tube does not have P4. This has an extremely modern phosphor, as phosphors go, that was developed for the CBS field sequential color system and viewfinders. This is a white phosphor. This is not blue-white phosphor. This is white phosphor. Like a fluorescent tube. It's P45 is the phosphor number if you'd like to look it up. This should be able to make a nice field sequential color television that can run at multiple scan rates. So I could build a single demonstrator that produces CBS field sequential color and ColRTel NTSC field sequential color. It could also work at the, I believe General Electric had a 525 line, 90 frame per second field sequential system, as did Dumont. The Aurora Designs World Converter, scan converter that I use for my antique television projects, produces all of these standards. So I should be able to build a little multi-standard field sequential color television with that tube. It's the best thing you can do with a black and white tube is convert it to color. So those are the projects. Those are where we are at. That is the status. I'm the lab guy. And I'm alive. And so are my projects. Lab guy out.